Lesson 9, Writing Addition and Subtraction Expressions. So let's take a look at creating a bar diagram to represent 3 plus 5. So 1, 2, 3 plus 5, 1. You're drawing this in your notes. 5. So we have 3 plus 5. So now we're going to draw another bar diagram to show 5 plus 3. So 1, 2, 3, 4, 5, and then 1, 2, 3. How do I know if those two expressions are equivalent? And we've sort of done this before. How do we know that 3 plus 5 is equivalent to 5 plus 3?
Because both have the same sum.
Right, they both have the same sum, and what is that sum? So, yes. Oh, that's really sloppy. I can't see the shadow. Yes. Both 3 plus 5 and 5 plus 3 have a sum of 8. Alright, so apparently this page didn't record. So while everybody's finishing their notes, I'll summarize it quickly. We have a number increased by 2. So that's n plus 2. And we know that we could also write it as 2 plus n. But I think that n plus 2 is the righter way because the number is being increased by 2. We drew a bar or model to represent n plus 2. And we noticed that the box for the variable is a different size than the ones that are used to make up the 2. Okay? Because it probably represents a different value. It could be smaller than 1. It could be greater than 1. But we still have to draw my boxes different sizes. Okay? Let's continue. Write an expression to show the sum of m and k. What operation would sum be for? What is it? Addition. So we have m plus k, or we could do k plus m. Which property can be used in examples 1 through 3 to show that both expressions given are equivalent? We showed on the very first slide 3 plus 5 is 5 plus 3, and we did this in lessons 1 through 8 too on the number line. Nice. The commutative property of addition. Okay. We love the commutative property. We get the same sum either way. Now let's take a look at 10 minus 6. Let's draw a bar diagram to model this expression. What is it that I have? What is my total quantity that I'm taking away from? 10. So this whole bar diagram represents 10, and you're drawing this in your notes. I'm taking away 6. So what expression could I write for 10 minus 6? What could I write? 10 minus 6. Now, could I do 6 minus 10? No, subtraction is not commutative. That wouldn't work. So let me tell you a little secret. When students are writing expressions, the thing they get most tripped up on is the subtraction, because you have to figure out which comes first. You have to figure out your quantity that you're taking away from. So addition, even though there's a right or wrong answer, it wouldn't change your answer. But we can't use 6 minus 10 because if we started with 6 and tried to take 10 away, the models would not match. The models for 3 plus 5 matched 5 plus 3. The models for n plus 2 matched the model for 2 plus n. But the model for 10 minus 6 would not match the model for 6 minus 10. Okay, let's continue. How can we write an expression to show 3 less than a number? What do we have? What is the quantity that I'm starting with that I'm taking away from? Do I have a number n that I'm taking 3 away from? Or do I have 3 that I'm taking n away from? So it's 3 less than a number. So what am I starting with? Do I have n minus 3 or do I have 3 minus n? Those are two very different expressions, so we have to pick one. Which one do you think it is? Very good. We're starting with the number and then subtracting 3. So to draw a model, all right, I did these backwards, but that's okay. So my model, my total quantity is n, and I'm taking 3 away. So you label your total quantity with a bracket because we're not labeling our pieces like addition. Okay? The number C being subtracted from the sum of A and B. I see two different operation words in here now. I see subtraction and I see sum. So first of all, how would I represent the sum of A and B? Yeah, A plus B. Now is A plus B being subtracted from C? Or is C being subtracted from A plus B? It says C is being subtracted from the sum of. So what would come first? So it would be A plus B minus C, or would it be C minus A plus B? Excellent. So we have to have the sum, and then C is being subtracted from that. Do I need parentheses? Would that change the answer? Why not? Why? It wouldn't change the answer. Why? Not that. Order of operations tells me to add first anyway. So I would add before I subtracted because of my order of operation rules. So I don't have to subtract because of order of operation rules. I don't need parentheses. But now let's look at example 7. Let's write an expression to show the number C minus the sum of A and B. So look at the board, please, ladies. C minus the sum of A plus B. Do I need parentheses now? Because this would have me subtracting before finding the sum. But it's telling me I'm supposed to subtract the sum. So do I need parentheses now? Yes, I do. Because that would mean something totally different. And we'll prove that in a minute. Without the parentheses, only A is being taken away from C, where the expression says that A plus B should be taken away from C. Okay, do you see that? Let's prove it. So here's our one expression, C minus A plus B with the parentheses. Here's our other C minus A plus B without the parentheses. So copy the two expressions, and let's replace A with 1, B with 2, and C with 3. So C is 3 minus 1 plus 2. 3 minus 3. 3 minus 3 is 0. Here we have 3 minus 1 plus 2. Order of operations tells me to subtract first. So 3 minus 1 is 2 plus 2. 2 plus 2 is 4. You see the difference those parentheses makes? Because here I'm subtracting the sum. Here I'm subtracting A. So that makes a difference. Okay, let's continue. Write an expression to show the sum of 7 and 1 plus 5. So sum means to add, and we could write that either way. That's the bottom of page 40. All right, top of page 41, number 2. Write 2 expressions to show W increased by 4. Then draw models to prove that both expressions represent the same thing. So we have W increased by 4 or 4 plus W. I think the righter one is the first one because it's W increased by 4. W is the quantity that I'm starting with. So here I have my bar. So that's W and that's 4. I don't know which number is bigger. I just made the W bigger. So on this one, 4 plus W. Notice both of my models used 4 as the smaller one. And both used W as the larger one. Both models should be the same size because they're representing the same quantity. Okay? Write an expression to show the sum of A plus B plus C. Oh, I just said it. So we have A plus B plus C. Anybody want to do something different? B plus A plus C. Something else? A plus C plus B. What else?
C plus B plus A.
One more. We have 2 that started with A, 2 that started with C.
B plus C plus A.
Awesome. Awesome. So let's write an expression and a model showing 3 less than P. All right, what operation is this? Subtraction. So ding, 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 careful, careful, careful. Red lights, red flags, everything else, we need to be careful. What is my original quantity, 3 or P? What am I starting with and taking away from? Everybody? P. Haha, they said P. All right, so my quantity that I'm starting with is P. I'm taking away 3. So P minus 3. It asks for an expression and a model. So P minus 3. Now number 4 is going to look very similar. I wish they were on the same page. Oh, for you they are. All right, let's take a look at number 5. Write an expression to show the difference of 3 and P. Difference means subtract. So 3 minus P. This time I'm starting with the 3 and taking away from it. Those mean 2 very different things. 4 and 5 mean very different things. Write an expression to show 4 less than the sum of G and 5. So what am I starting with? What am I starting with? Well, it's 4 less than something. So I need to know the something first. So what is my something? All right, G plus 5 minus 4 or 5 plus G minus 4. And we don't need parentheses because PEMDAS tells us to add first. So because PEMDAS tells us to add first, we don't need the parentheses. But technically, if you put parentheses there, I don't think it would be wrong. They're they're not necessary, but if you put them there, I wouldn't mark you wrong because you're looking for the sum and then you're subtracting. But you don't need it because PEMDAS has us adding first anyway. We don't need the parentheses to tell us that. 4 decreased by the sum of G and 5. So what am I starting with? Am I starting with the sum or am I starting with 4? Starting with the 4 because 4 decreased by the sum of G and 5. Do I need the parentheses now? Please take your notes. I need the parentheses now because otherwise I would subtract first. I don't want to subtract first. I need that sum. It says to subtract the sum. So those parentheses are screaming, hey, you gotta add first. You gotta add first. Absolutely. Good thinking. Very good. Should 6 and 7 have different expressions? Absolutely. You don't have to copy this whole thing down, but let's just talk about it. In 6 and 7, we're starting with the sum and subtracting 4. But in 8, we're starting with the 4 and then subtracting. So in number 6, it's the sum minus 4, and 7, it's 4 minus the sum. Okay? Less than and decreased by are 2 different words that have 2 different meanings. The sum, less than and decreased by have different meanings. So be alert, be aware. Don't let those subtraction words trick you. Okay? So sum minus 4, that was decreased by. Oh, I've got that backwards. This is 4 less than, and this was decreased by 4. Okay? So watch those cue words and make sure you have them correct. Don't let them trick you. All right, right now we're going to turn to lesson 10. Okay, now for lesson 10, we're going to continue looking at writing expressions, but today we're going to look at multiplication. We just did addition and subtraction. Now we're going to look at multiplication. This should look very familiar to the stuff we did in lessons 1 through 8. In fact, some of this was even just on your 1 through 8 quiz. So this is why we're going to do this one quickly because it's stuff you kind of already got. All right, we already know that to write multiplication, if we saw A times B, we know that we don't want to use the X because then the X could look like another variable instead of the multiplication symbol. So we know that we can use the dot. We know that we can put the 2 variables next to each other. We know that we can also use parentheses because we want to get rid of using that X so that it doesn't look like another variable. We also looked at the following vocabulary words. In this expression, 5x minus 3, we know that 5x is a term. 3 is a term. We know that the 5 is the coefficient. We know that the x is variable. And that 3 is called a constant because it will constantly be a 3. It will constantly, continually, always be a 3. So it's constant. So now let's take a look at example 1. That says 6 times b, but it could get a little confusing. So let's write it using the fewest number of symbols and characters. So this would be 6b. So let's label it. 6 is our coefficient, and b is our variable. But when we multiply 2, you want to take your notes, please? When we multiply 2 numbers together, what are those 2 numbers called being multiplied? Factors. So those are also both factors. That whole thing, the whole 6b, is called a term. And since 6b is our answer, that's also our product. And you're writing all of this in your notes. Because what's 6 times b? 6b. So that's our answer. We don't know what b is, so we leave it as 6b. So that's our product, because that's our answer. 3 times 4 times h. What's that one? Who wants to guess? What's 3 times 4?
12.
What's 12 times h? So this is 12h. 12 is our coefficient. It's also a factor because it's one of the numbers being multiplied together. H is our variable and a factor. Gentlemen, please stop talking and copy your notes. But the whole thing is also a term and our product because that's the answer. All right, a couple more. 2 times 2 times 2 times 8 times b. What's that? Nice. 8ab. 2 times 2 is 4. 4 times 2 is 8 times a times b. The coefficient always comes first. I have no reason why. It just is. There probably is a reason. I just don't know it. The coefficient always comes first. And look at how nicely those variables are like in alphabetical order. Because multiplication is also commutative. So we can rearrange them. We're not going to label all of those because we're running out of time. What's 5 times m times 3 times p? Can I rearrange those? Could I do 5 times 3 times m times p? And then what would my product be?
15 MP.
Right. The variables are in alphabetical order. So you can multiply your constants together, and that becomes your coefficient. What's 1 times g times w? Yeah, so what's GW times 1? GW, we get the identity back. When we multiply by 1, we get our identity back. Whoops. So we don't have to put the 1 there. When 1 is your coefficient, you don't have to. It's a lot of work just to get that. There we go. We don't have to put 1 down when it's your coefficient. Okay, and I actually crossed that off on some of your quizzes, you'll see. I didn't take off points, but I did cross it off. All right, now for example 2, they're asking us to expand the multiplication expressions to rewrite the expressions using the multiplication dot. Okay, so what's 5g written as a multiplication expression?
5 times B.
Yep, 5 times g. What's 7abc as a multiplication expression? Yep. What's 12g as a multiplication expression? What's 3h times 8 as a multiplication expression? Awesome! I thought somebody might get tricked on that. What's 7g times 9h? Very good. Very good. I'm impressed, boys and girls. You don't have to rearrange them. They're just asking you to expand it, so you don't have to organize it. That's okay. Find the product of 4f times 7g. So let's just take a look as if I expand this a little bit. 4 times F times 7 times G. Now, kind of indicating what your question was about rearranging them, I could do 4 times 7 times F times G. What's 4 times 7?
28.
So this would be 28FG. Variables are in alphabetical order. Your coefficient comes first. What's 3DE times 9YZ? What would that one be? Oh, I jumped right into the product. Okay, so this one, if it's easier to expand it, 3 times D times E times 9 times Y times Z. If it's easier to expand it first, you can. 3 times 9 is 27, and then all the variables in order next to each other. You do not, as long as the directions tell you you don't have to expand it, you don't have to expand it. So double the product of 6y and 3bc. Well, first let's find the product. So we have 18, God bless you, BCY, but they want us to double it. To double it means to multiply it by 2. So you're writing it, that's not correct, that means something different. So please don't go ahead. Please copy the notes that I'm writing on the board. Okay, so read the directions carefully on the problem set so that you're giving them what they're asking for on the questions.